For today's lesson, we will be learning to use composition and decomposition to determine the area of irregular polygons on a graph. So for our mini lesson, or warm-up rather, right now, we are going to be finding the area of a trapezoid, which is not an irregular polygon, but this will help us understand how to find area using composition and decomposition on a graph. So for this first question, I personally think that if the shape is a perfect polygon, kind of like this trapezoid, that it is easier to use decomposition than it is to use composition. But we could use either one. So for the first problem, I'm going to use decomposition. So I am going to break down the inside of our trapezoid into familiar shapes that we do know. So I am going to draw a line like this, which is going to give me a triangular shape. And I am going to, in another color, break down the other side, giving me an additional triangle over here, leaving me with a square or rectangular shape in the middle. This is super important because it's going to help me determine what the base and the height is of the shape. So I'm going to start with the blue square. I know it's a square, rectangle, excuse me. I know it's a rectangle because my side lengths are different. So I know rectangle is area equals base times height. Area equals, now my base is from this point till this point right here. I don't know what the base is. I know that the base of the green triangle is 1. So I know that a rectangle has 2 equal sides. So since the top is 3, I now know that the bottom is 3. So my base is 3, my height is 4, and area equals 12 units squared. Now I'm going to find the area of the green triangle, excuse me. And I know area equals 1/2 base times height. Area equals 1/2. The base we said was 1. And the height is, well, you tell me, is the height 5, do you think, or is the height 4? And think about why. So hopefully you know that the height cannot be 5 for 2 reasons. 5 is a slanted line, it's not straight, and it also is an acute triangle. It is not a 90-degree angle, which means that this side over here must be my height. The rectangle I know has opposite sides are equal, so since this side is 4, I know that this side must also be 4. So the height is 4. I am going to use my shortcut, and I know 1/2 of 4 is 2. And 1 times 2 is 2, giving me an area of 2 units squared for my green triangle. Now last, I'm going to work on this purple triangle. And once again, I know the formula is area equals 1/2 base times height. It's my puppy crying, sorry. Area equals 1/2. Now, I know that the height is 4, once again, but we got to figure out what our base is. So now that we're on a graph, we can actually look at each unit. This is going to be 1, 2 spaces, telling me that my base is 2. And I'm going to use my shortcut again. 1/2 of 4 is 2. And 2 times 2 is 4, giving me area equals 4 units squared. So if I use decomposition, now I'm going to have to add all of my sides, my areas, excuse me, together. So I have to add 4 plus 2 and 12, giving me a total of 18 units squared. Now let's solve this exact same problem, but this time we're going to be using composition. So for composition, we are going to, let me see if I can move this up. I need some space. We are going to be drawing on the outside. So for composition, I'm going to be turning my whole shape into one big rectangle. This dot is a little bit off. That's okay. One big rectangle. And now I need to find the area of my entire rectangle. Area equals base times height. Area equals, well, I knew that this was, for my last one, I knew that this was 2, and this one was 3, and this one was 1, giving me a total of 6. So the full base is 6, and the height, before, they told us it was 4. So that means if this line is 4, this line over here must also be 4. And I know the area of the entire shape is 24 units squared. That's more than the area we got because in the last shape our area was only 18. So when you use composition and you make the shape bigger, we have to eliminate the shapes that we added on. So one shape I have to now eliminate is this triangle over here that I'm coloring in red. And once again, I have to do area equals 1/2 base times height. Area equals 1/2. The base of my shape is only 1. And the height is 4, just like on the other side. Half of 4 is 2. And 1 times 2 is 2, giving us area equals 2 units squared. Okay, that's the red triangle. So this part is 2. 24 is more than the shape was originally, so I have to now take away 2 from this triangle, leaving me now at 22 units squared. So that means the area that I have right now, that is 22 units squared, represents this shape right here. Minus that triangle, it's this entire shape. But that's still bigger than my original shape. My original shape did not have this triangle that also exists on the other side. This triangle over here needs to also be eliminated. So, once again, area equals 1/2, base times height, area equals 1/2. Our base was 2 units, and our height was 4. Luna? So, 1/2 of 4 is 2, and 2 times 2 is 4. Area equals 4 units squared. So now what I'm going to have to do is I'm going to have to take away this 4 from 22, leaving me with 18 units squared, which was the same answer as the first problem. The next slide will be on a separate video.